Welcome to our webinar Process Lifetime Prediction with DSC and Kinetics Neo. My name is Thomas Henel. I'm the Regional Sales Manager of Germany West. In this webinar, I will give you a short introduction why the Kinetics Neo is helpful for your process. I will show you the data import into Kinetics Neo software, the model-free and the model-based fit from your results, the process prediction with Kinetics Neo, the process optimization, and at the end I will give you a short conclusion. What are the benefits of the Kinetics Neo for your process? The Kinetics Neo help you to improve your pod life, your processes. It's help you to save costs. You can increase your development, and at the end you will produce a higher quality for your products. On the right side you can see the DSC 214 polymer, and on the left side you see the DSC measurements of an epoxide resin with 3 different heat rates, 5, 10 and 20 Kelvin per minute. Kinetics means speed. That is the reason why you need 3 different heat rates. We see the 3 exothermal big curing peaks, but also we see small endothermal peaks at the beginning, and the shift to higher temperature with increasing heat rates. The idea behind Kinetics Neo is that you can predict other conditions, for example heat rates or isothermal conditions, if you can describe your real measurements with only one mathematical model fit for all measurements. We can import the results by ASCII code files into the Kinetics Neo software. Besides the DSC, you can import also results from other thermal analysis, for example the thermal gravimetry, dilatometry or rheometers. After the import, you can use a baseline and border to choose the right part of the curve for your modeling. You can select different types of baselines for your results, such as tangential or linear. In our example, we don't need a baseline or a border, we use a complete curve. In the next step, we try to fit our results with the model-free fits. Model-free fits are fixed models based, for example, on an STM standard and standard test methods for Kinetics parameter, or we can choose to fit our results with a numerical optimization of the parameter, such as the activation energy or the pre-exponential parameter. The numerical optimization gives a very good fit of our results with a correlation coefficient of 0.998. But what we see is that the first small peaks are not fitted. What we now want is to fit the whole curve. In the model-based part, we can fit each reaction step by step. We start with a reaction A to B with a reaction type of CN with autocatalytic. Epoxides are often reacts under this reaction type. We got now the peaks and we can pre-adjust the peaks with the arrows on the left side. We click then on Optimize to set the fit. And after that we press the button on the bottom for Optimize the whole model. The resulting fit is very good, compatible with our numerical optimization, but we have the same problem again. The small first endothermal peak are not fitted. Therefore, we have to insert a new step. We copy our model and then we insert a new step with a double arrow under the reaction step. We have now fit curves with 2 peaks, and with our adjustment arrows we move the peaks near to the effects. The zoom function is very helpful to adjust the small peaks to the endothermal effects at the beginning. With the optimization of this step, we see with the zoom function that we are pretty close to the small effects. We can now optimize the complete fit. And we get now a correlation coefficient of our model for 0.999, which is better than our model before and the numerical optimization. After we finished our model, we can go to the simulation part of Kinetics Neo to create predictions of the epoxide resin system. We change our view from temperature to time and DSC signal to conversion for the predictions. The first point is isothermal. We see now the conversion versus time for our system by different isothermal curing temperatures. In the left column we have the option to set methods or model which we wanted to use for the prediction and the minimum and maximum temperature range as well as temperature steps and time. We select for the example the 130 and the 150 degrees curve to see the difference between them. Of course, the conversion of 100 degrees is faster in contrast to 130 degrees. To see this better, we can change the temperature steps from 10 to 20 degrees. At 150 degrees, the system achieves a conversion of 1 between 80 to 90 minutes. But the system is not fully cured for 130 degrees after 100 minutes. The next point in the list is the isothermal lifetime prediction. This is especially interesting for the pot life of an epoxide resin. For example, if we know that our epoxide resin is processable up to a conversion of 0.1, which is 10% of the conversion, we select this curve on the right side. Now we can easily see on the chart that our epoxide resin is processable at 30 degrees ambient temperature for approximately 7.5 hours. This gives us the ability to improve our pre-processing handling of an epoxide resin. Kinetics Neo provide also predictions for dynamic heat rates, which show us the influence of the heat rates on the conversions. Multi-step prediction to simulate a curing process with changes in the heat rates. Climatic prediction with climate data from all over the world, which is especially interesting for the pot life of a product. Or the time temperature transition chart to give an overview of the conversions over time and temperature. The last part of the Kinetics Neo software which I want to present you today is the optimization part. Often it is important to have a linear conversion to avoid internal stresses of a product, which can produce uncontrollable shrinkage and warpage. We insert in the middle the process data of our curing furnace. For example, our real process furnace has a minimum temperature of 20 degrees and a maximum temperature of 150 degrees. A minimum heat rate of our furnace is -2 Kelvin per minute and the maximum heat rate is 10 Kelvin per minute. And what we want is a linear conversion rate of 1%. After we press the calculation button, we get a nice linear conversion over the main part of the curing. But the best is Kinetics Neo creates a temperature program for this process, which can be used to optimize your real curing process. We see an increase of the temperature up to 110 degrees to activate the curing process, and after that we have to reduce the process temperature because of the autocatalytic reaction of the epoxid to avoid an overshoot of the curing rate, that we stay in a linear curing rate of 1% per minute. This tool is very important to optimize your processes to save money in your development processes, because you can reduce time-consuming try and error experiments, and Kinetics Neo gives you the ability to start your development for a new process with a solid database. We are now on the end of the webinar. We had showed you that the data handling of the Kinetics Neo is easy, and that we can increase your knowledge about your process with a minimum of experimental efforts based on few DSC measurements, without an expensive and time-consuming try and error experimentals. Kinetics Neo can reduce your development effort, and this improves your processes, your products, and cost efficiency. Thank you for watching this webinar.